Okay guys, today we're going to look at finding the mean of a normal distribution. So whenever we have a normal distribution question, they'll always tell us that the data has been presented in a normal distribution way. So we're going to look at what we can do to find the mean of the data. So up till now we've been loading in different things. So we've been either loading the probability, the mean, the standard deviation, or some value. So there's four sort of things. So if we don't have the mean, the only way we can find is if we have the other three things. So if we're looking at it, all right, let's say we're looking to find out what this is. We don't know what it is. We need to know our value, let's say it's K. We need to know a probability, all right, whatever that is, and we need to also know the standard deviation. All right, so the only one we're missing is mean. All right, so that's the situation we've got. And so what we do is that because we don't have the mean, we have to take the problem. So if we have a problem like find the mean, and it'll always say of a normally distribution of light bulb life lengths if a study was done and found 28% last longer than 24 hours. 124 hours, let's say. We know the standard deviation is 12 hours. All right. So by something they know that the standard deviation is 12 hours. So they've given us all of this information. So the three things we need to know are here. Here's the probability, 28%. Here's the K number, whatever it happens to be, and the standard deviation. All right. So to start off with, we pretend we don't know the standard deviation or the K number. So what we do is we standardize it. So what we're going to say is that if we've got 28%, so 28% is here, 0.28, all right, and we want to know this value, okay? We can use the standardized values, so the mean equals 0 and the standard deviation equals 1, and we can put this into our calculator. In the inverse mode, so menu to standard distribution, normal, inverse, and we're talking about which side? We're talking about the right side. So right, the area is 0.28, and we're standardizing it. So we're going to put in the mean of 0 and standard deviation of 1, but the other way around, because we always put standard deviation inverse. So 1 and 0, and that tells us that our K value will equal 0.5828. But we haven't got a standardized thing. We've got all of this application-y type of thing. We know about that K should equal 124. So there's a formula, and it's given to you on your formula sheet, and it says that the X value, the standardized value equals X minus the mean over the standard deviation. All right? Okay. So now that we found out what K is, we need to use this formula to find out what X is, because we're after, mu is. We need to know what the mean is. So we've got this one, and this one now. So 0.5828 is equal to 124 minus the mean over the standard deviation of 12. All right, so if we use algebra to solve this, we're going to go 0.5828, remember 4 decimal places, times 12 equals, so 124 minus the mean is equal to 6.9936. So now if we swap these two over, we will find out what the mean is. So the mean is 124 minus 6.9936. 124 minus, the answer is 117 hours, approximately. All right, so what we're saying is this value was 124, so the mean had to be this side of it. So 117 is less than it, that our answer is 117. All right, so you've got to use the standardized value to find K first. Okay, so now what we're going to do is we're going to have a look at finding a standard deviation. So same sort of thing, but a little bit different in its working. So we're still going to use that formula. I probably shouldn't have wrote that out, but never mind. Okay, so again, here's our picture. This time we're going to have the mean. We're going to know what that is. We're going to know a value. Let's say we know this one this time. We're going to know that all of this probability equals 0.68. Okay, it's the probability. 50%, 18%. Okay, so what would the question look like? Bags of flour, because there's not much around, of course, are allowed on the shelf if they weigh more than 495 grams, 500 bags of flour. All right, so we're going to say that the mean of flour is 500 grams. All right, because that's what the bag actually says. So in the shop, that's what the average has to be. But the and standard deviation and the probability that they'll be less than, that they'll be greater than, less than 495 grams is 68% of the time. All right, so we've got the three things. We've got our probability, got our x, and we've got a mean. Okay, so again, using that formula, z equals x minus the mean over the standard deviation. All right, what have we got? So we draw our picture again. We don't know what standard deviation is. We know this is 500, we know that this is 495, and we know that this is 0.68. But we've got to again use the standardized formula. So we've got to put in a standardized formula of 0 and 1. So we're back to our calculator. Shift to distribution normal, inverse normal. This time we've got, again, the right tail, so that's good. The area this time is 0.68. The standard deviation 1. All right, so the standard deviation 1 and the mean is 0 and the area is 0.68. And the tail is right. Okay, so what have we got? We've got negative, so our z value equals negative 0.4677. That's because it's on this side of the mean. That's 0, so negative is coming this way, all right? So negative 0.46 there. Now we're going to use the formula. So we want to find that negative 0.4677 equals the value, which was 495, minus the mean, divided by what we're trying to find, which is the standard deviation this time. So we've got here negative 0.4677 equals negative 5 over the standard deviation. Remember, we can swap these two over to find it. So standard deviation equals, don't forget, standard deviation equals negative 5 divided by negative 0.4677 is 10.7. 10.7 grams. All right, so that's how you find the standard deviation. These two types of things are excellence questions. They're quite often the last question in this particular part of the exam, the normal distribution part. And if you can learn to do it, and there's only 2 examples, I'm sorry, in the book, but if you can learn to do it, then it's a good, easy E7. Okay, so we do want to learn to use it for most of you, because we do want to get that 7 marks easily. Okay, so we'll leave it at that for today. Okay, ciao.